Okay, so well, just now we talked about the case one, but it is only one possible case. So just now we have two consecutive red nodes, and A and B is the red child of A. There is another possibility. When we have two consecutive red nodes, and B is the left child of A, does that change anything? And the answer is no. We are still going to color the X and the grandparent to be red. So B, which is the X, and the grandparent to be red. And then for the parent and the uncle, they are both black. So in this case, well, in the case 1, it doesn't really matter whether the new node X is a left child or a red child. What we are going to do is, for the new node X and the grandparent, we color both of them into red, and then for the parent and uncle, we color them into black. And then we are going to assign the new X to the grandparent, and then we are going to fix the tree all the way up. Okay? So, and the case number 2. So case number 2 is a tricky case because the rule is if the new node X uncle is black, and then the node X is a red child. So the scenario should be like this. So for the new node X, it is a red child, and then the parent A is also red. But for the uncle is a black. So you may ask, why it is a triangle? So think about that. Before we inserted the X, what was this tree like? So before X, we should have, let me change the color. Before we insert X, and then at that time, we should have a C, and then we have a triangle here, and we have a red A. I have to change the color again. So we have a red A, and after that, underneath the A, we have two triangles. Okay, so this was the tree before we inserted the X, and at this time, if the C is the first black node, and then for all the little triangles, they have the black height of n, and this means for the C, it has the black height to be 1 plus n. It is guaranteed. So for all the little triangles, they are black nodes, and they are black nodes, and they all have the same black height. Okay, so after we inserted B, now the tree will be like this. So B's parent is a red node, and then the node X, the new node X, is a red child. So and the uncle, which is this part, the uncle is black. So what we are going to do in case 2 is we are going to do a left rotation on A and B. So we are going to make B the new parent. Okay, so we are going to transform the case 2 into the image on the right side. So you may ask, it doesn't really solve the problem. So on the left side, we have two consecutive red nodes A and B. Now, after the left rotation, we have two consecutive red nodes again. They are B and A. So we didn't solve any problem. However, we have transformed the case 2 to case 3. Okay, so case 2 itself doesn't solve the problem. We are still violating the rule. However, we are going to move on to case 3. So for the case 3, that is, we have the new node X as the left child, and then the X parent B is a red node, and for the X uncle, it is black. Okay, now you may find this tree is a little bit imbalanced, right? So in this case, we want to do a right rotation on the node C and B. After we do the right rotation, and then B will be the new parent, and A and C will be two children. And at this point, B stays black, and A and C, they are both colored into red. So this will solve the problem. So let's step back again. So for the case 2, B's ankle is black. However, B is the red child. We don't want that. We want to do a rotation so that, well, B has a red child, B has a left child A. And after that, we have C, B, A. And it transforms to case 3. And for the case 3, we want to do another rotation, and then now B is the new root of the subtree, and then A and C, they are both the children. And we color A and C both red, and B stays black. So now it fixes the tree. So you may find that's already hard enough. We have already talked about case 1, case 2, and case 3. And guess what? We have case 4, 5, and 6. But the difference will be case 1 to 3 hold if X parent is the left child. So X parent is the left child, and then we go to case 1 to 3. However, if X parent is a right child, and then we are going to go into 4, 5, and 6. Well, it is just they are just symmetric to case 1, 2, and 3. Okay, so how about deletion? Deletion is really hard and really tricky. Well, what I'm requiring you to do is to read the textbook, which is this one. So take a look on the textbook. You don't have to worry too much about the code of the deletion. However, by reading the images, the visualizations, you should get some idea on how the deletion can be done. Okay, so that is the end. Well, in last lecture, we talked about the cool thing about the red-black tree. As long as we maintain those 5 properties, a red-black tree will guarantee to have the height h as O log n. That is the cool thing about the red-black tree, but we have to hold those 5 rules. And for today's lecture, we are using insertion as an example. And we discuss if we insert a new node into the tree, how we are going to do a lot of the magical, tricky manipulations of the tree so that we can maintain those 5 properties. The goal is, as long as those 5 properties are maintained, and then we have a really nice and really cool red-black tree. Okay, so I will see you next week. Bye.